Alright, so this is going to be a video lesson on the proper way to solve an absolute value equation. And generally speaking, what that means is this will be a little bit longer than the normal, here's a problem, just straightforward, here's how you do it. But I will, in the description to this video, link a time as to what that video just starts. So if you wanted to skip all this explanation, then you could do so, and you could go to just seeing me do some problems right away. So the first thing here is let's talk about absolute value. Let's talk about the concept of absolute value because you need to understand the concept of absolute value to understand why it is and how you solve them. So first off, I have here that it says y is equivalent to the absolute value of x versus y just being equivalent to x. So we need to understand what happens or what goes on within the function and how it's created so that we can understand how we would solve an equation that would say something like the absolute value of x is equal to, say, 5 or whatever you may have, and building that idea. So the first thing I'm going to do here is in blue, I'm going to graph y equals x. So y equals x, so to graph a line, you can either use a table. So if you want to use a table, okay, we can just get a couple points here. So we'll go -1, 0, 1. So in this equation, if I plug -1 in, I get -1 out. If I plug 0 in, I get 0 out. If I plug 1 in for x, I get y equals 1. So if I were to plot those points very quickly, I could plot 0, 0, okay, plot the point 1, 1, plot the point -1, -1. And what I've got very quickly drawn here is this idea of y equals x. So now absolute value basically comes through, and we're going to talk about how does this differ. Well, absolute value is still looking at the graph of y equals x. However, the absolute value says, well, you can't have the negative value. So any of these values down here on that same exact line, they're saying these are no longer legitimate points. I can't use them. And they say it's not that you can't plug in the negative because you're still allowed to plug in the negative value. It's just that that answer, when all simplified, will not be negative anymore. So how is it that I mathematically take something that is down here and it is currently negative, and how do I then flip it up here so that it then becomes positive? And the way you utilize this is through the multiplication property of -1. And what does a multiplier by -1 do? Well, a multiplier by -1, so if I take my original point here, okay, and I talk about the absolute value of x and what the value of y would be, all right, it's actually going to take the current y value or the current output that I would have, and it's just simply if you multiply it by a negative value, so -1, okay, so -1 times -1 ends up producing this new number, which is now +1. And now all of a sudden, I've got this new graph. So if I start taking all of these points that are on this graph on here, and I multiply them by -1, what it's doing is it's flipping them up to the positive zone. And what you start to have is that you now start to have this graph of okay points. So when we look at the absolute value, okay, what we're concerned about is when does it fall below 0? When is its zeroing value for the function occurring, so that at that point we know we need to begin to multiply those things by -1. So in this case, it happens right at 0. So if I plug 0 into this function up here, I'm okay. I haven't fallen below the x-axis, which would show or indicate to us visually that we have a negative number. But as soon as I plug -1 in on the original function, the outcome would be negative. Well, absolute value says that's not okay, so multiply that outcome by -1 to flip it back to the positive side. So what you have here now in green, okay, is this new graph that is drawn. And what you get here, okay, is that negative side, okay, that was once there, has now been formed, and what you've got is this graph that kind of looks like a V, and that will be that telltale sign that you have an absolute value equation on a graph because you've got a V. You've got to a point where it's getting to the x-axis and then it's stopping it, and that's if there's no like vertical shift or everything. I'm talking very plainly here, just an introductory, because you could shift this graph up and down. The point you want to know is that at one point there will be a value at which you can't go any lower. So the important piece of this is recognizing this V shape, and the V shape will come to a very distinct point. It will hit that point, and then it will start reflecting almost on the other side with a very, very, very symmetrical pattern, okay? And that's because it's taking a linear function and it's stopping it and it's literally reflecting it back up where the point would have been negative to start with. So it's an important concept and understanding that literally what you are doing is any value that would have been negative, you're multiplying that by -1. And that's going to be the key here to understanding how it is that we solve these equations. So let's go ahead and look at some of those equations. So an equation that we'll take a look at here is something like, what happens if I have the absolute value of x is equivalent to, say, 5? And we'll start off with the most introductory level to build this idea. So what I actually want to have here happen, okay, I'm going to draw a little sketch, is that the absolute value of x, we just talked about this graph, kind of looks like this. All right, I want to know the exact value, all right, what value will x have to be so that it has an outcome of 5. So we're looking for it to obtain this outcome value of y of 5. So I want to know right here, what is the value of x? And over here, if you notice, there's another place that the line of 5, okay, the value of 5 will occur. So what I've got going on here, because the absolute value, it goes upwards on both sides here for this thing, I've got two possible answers for x. And this is where this idea is going to come in. So this side, okay, in blue, was the original function, okay? This side was the original side of y equals x. And what we notice there is that that function was not altered. So I can treat this, okay, as if it were just x and as it was just the original equation. And I can say, okay, well, what if I had that function of x just equaling 5? Because the function of x would just absolutely come to get to 5. Now, the other thing is okay, well, how the heck do I get to 5 on this other side? So I'm going to do this in red. Okay, so this side here. All right, so how the heck did this side get to be the fact that it got -5? Well, we have to apply, well, how did I get these values in the first place? Well, these values existed in the very, very first place because we had this graph that went down here of y equaling x, and what we did to these values down here is we multiplied them by -1 and it flipped them back up here. So one of the things that a lot of people miss out on and kind of go through and say is they teach us, oh, you should know absolute value. The answer has to be positive. So what number can I plug in there so that the outcome would be 5? And well, you know, that's a nice quick way of learning it, and you know, and it's a nice way to tutor and say to people who are really struggling with this concept, it doesn't really hit home the idea that you took that original x value, that original input that you created, all right, and you multiplied it by -1. So the absolute value, okay, is a grouping symbol, and you can't just take an x out with a mathematical property. You have to apply what its significance and what its meaning is. So the first time is you had this function as normal, and then the second time is you've got this function that you multiplied by -1. So you took the x and you multiplied it by -1, and then that got you that other value of 5. What I don't like to see is I don't like to see some people, they go, oh, x just equals -5. And the reason I don't like that is because, no, I'm not trying to get to -5. I want to see the original thought and the original mathematics behind it, because it's very, very important in later courses such as you know, your trigs and your calculus, that you truly understand that it's the function that got altered to obtain the same exact value that the original parent function would have had. So with that being said, it is much more beneficial for you to learn that you multiplied that original function by -1, and then that would produce you the value of 5. So now we would then go and solve this equation. So to solve this equation, we would divide by -1, divide by -1, and you get x equals -5. And now I know some of you may sit there and go, well, what the heck? I could have just said x was -5 from the get-go. You're absolutely right. The problem with that is that you're missing the whole idea of absolute value. So when you have to do harder equations and when you have to do higher level classes that have harder things that deal with absolute value, you're missing that base foundation. So I hope the goal of this video is to establish that base foundation. So let's go on to another one then. So let's make it a little bit harder. So we have the absolute value of, say, 2x plus 4. And that's going to be equivalent to, say, we'll make it 7, right? So again, I'll just make a quick little sketch so that you understand what's going on. So I graph 2x plus 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2. All right, so I plot my point, so I would graph a line just to show you this. So there's at 4, so I'm going to go down 2 over 1, down 2 over 1. So here's my graph coming in through very quickly. So this is the normal, okay, 2x plus 4. But then again, just to point this out to you one last time, is that these values are not okay because we have absolute value. So what absolute value will do is it will bounce all of those values up there by multiplying whatever these outcomes would have been by -1. Now, don't forget, you produce those outcomes by plugging that value of x on this line right here into this equation. So what you can simply do is, again, multiply this equation by -1 to produce the values over here, and you can leave the function as normal to produce the values over here. So what we're trying to obtain, just one last time here, is we're trying to obtain the value of 7. So 1, 2, 3. So I want to know, okay, the value of 7 is going to happen here, and this side will create the value of 7 as well. Well, if you notice, this point right down here was the critical point that we had when x was 0, and anything left of that, okay, we had to multiply by a -1. So the way you solve these is you apply a concept. There is no mathematical thing that you can do, okay, to get something out of an absolute value bar. There is no like, okay, let's do distributive property or something like that. You can't do that. You have to apply the concept of, okay, this function 2x plus 4 will be equivalent to 7 as the normal function, and that is demonstrated on this side. Notice I did not alter this side when I graphed the line as normal. It was only when I got past this critical point of 0 and this side here, okay, I multiplied those values by -1. So that produced this other line now going up that also got this value of 7. So what we do is we utilize that concept. We go, okay, the first time we did it, we had 2x plus 4 equals 7. The second time we did it, we just said, okay, -1 times 2x plus 4 is the other way I'm going to be able to get to the value of 7. And then all you have to do is begin to solve these equations. So what I can do here is I can go, okay, let's -4, -4, and I've got 2x is equivalent to 3. And then I divide by 2 on both sides, and I'll end up getting x equals 3/2. So the first answer is x equals 3/2. And then the second answer, I go down here. Now, a lot of teachers may teach or possibly show you that you would just say, oh, we'll just make it 2x plus 4 equals -7. Again, I don't like that because I want to keep intact what it is I'm trying to create. And the function wants me to create a value of 7. So you really need to understand that it is the original function that I'm altering by multiplying it by -1 so that I can then, all right, produce this value of 7. So we have that shown down here, so it's just a matter of solving it. So there's a couple ways you can solve. You want to do distributive property because it's comfortable. That's what I'm going to do. So I get -2x minus 4 is equivalent to 7. I'll add 4 to both sides, so I'm going to get -2x is now equivalent to 11. And then I'll divide by -2, so I get x is equivalent to -11 over 2. And then I have my two answers, and then I'm done.